Hi, my name's Jason Lauritzen. This is my final project recording for EDCI 411. It's going to be Introduction to Trigonometry and specifically learning the mnemonic device SOHCAHTOA. So the first thing we're going to do is take a look at my lesson plan using a modified workshop model. The first thing I would do for teaching this lesson is I would have this lesson plan up on my whiteboard, and the first thing we do is go through the introduction. So I'm going to introduce the definition and use of basic trigonometry functions and just give an overview of what we're going to be doing today. So this lesson is called SOHCAHTOA. It's unit geometry. This is actually a high school lesson. I know I'm going to be K through 8 certified, but I'm getting a basic math endorsement, which actually allows me, I can teach up through 10th grade math. It could be at a high school, but it's just limited up through geometry algebra 2 level. So the objectives, students will be able to define trigonometric ratios and then understand the definition of sine, cosine, and tangent, learn and use the mnemonic device SOHCAHTOA. The math standard, Idaho math content standard, we're using similarity, right triangles, and trigonometry, define trigonometric ratios and solve problems involving right triangles. Specifically, number 8, use trigonometric functions and the Pythagorean theorem to solve right triangles and applied problems. Our Idaho math practice standard is going to be number 2, reason abstractly and quantitatively. So we're not really getting into the meat and potatoes of this specific math standard, but this is the introduction that we're going to need to go into this deeper later. So it does fall under this math standard. There's nothing that's really specifically points at introducing the concepts, but you have to introduce the concepts before you can get into the deeper standards. So so we're gonna start with the introduction. I'm gonna walk through a trigonometry slides, introduce the mnemonic device. After that, the class would work on a flashcard game at their table to kind of just cement that mnemonic device. During that time, I would walk around, spot check, see if there's any issues they're having, fix individual problems per table. If it looks like there's a larger systemic issue with understanding, I would go back, reintroduce that to the entire class. Once we're through with that, we're actually going to divide the class up into partners and play a SOHCAHTOA trigonometry bamboozle type game. And then following that, I would have the students get out their math journals, reflect on what we learned today, go into, in their own words exactly what they learned. And like I've said before, I kind of use some keywords. This would be where I would spell out to myself what SOHCAHTOA means. If there's a better way for me to remember it, I would write it out in my book. So I've got the introduction done, and let's kind of walk through the lesson as I would teach it. So the first thing we're going to do is, like I said, this is a introduction. This is our first step into trigonometry. So this would be the time where I kind of walk them through what it basically means. So what is trigonometry? The branch of mathematics dealing with the relations of the sides and angles of triangles and with relevant functions of any angle. So kind of the overview is trigonometry is used at its basic, how it's used in its basic terms. I mean, there's a lot more information, deeper understanding we're going to get later, but just starting out. So important terms we're going to need for right-angled triangles. So everybody's pretty comfortable with this, with Pythagorean theorem. We know what the hypotenuse is, but we're now, the other sides, we're going to have to get more specific. So one thing we're going to use, well, let's walk through these. So the right angle is indicated by the little box in the corner. Everybody knows what that means. The other angle that we usually know is indicated by theta, which is like this circle with the line through it. So we're going to be using that symbol as an unknown angle. So the side opposite the right angle, which is the longest side, is called the hypotenuse. We've got that down. The two things we need to become more comfortable with, though, is the side opposite theta is called the opposite. So if we're either know this angle or we're trying to find this angle, the opposite side in our definitions is going to be the one that's the opposite of the angle. So if this is our angle, we go straight across, this is going to be our opposite. The side next to theta, which is not the hypotenuse, is called the adjacent side. So if this is our angle that we're working with, the opposite one is the one that's on the other side, and the adjacent is the one that's right next to it and isn't the hypotenuse. So now we're getting into what SOHCAHTOA actually means. So the way trigonometry works, the way we're using it in this case, is much like the Pythagorean theorem. If you know two sides of a right triangle, you can use Pythagorean theorem to figure out the other side. This is kind of the same concept. What it's telling us is if we know any two sides, the length, we can figure out either of these two angles. Or conversely, if we know one of these angles and any one side, we can figure out the length of any other side. So you're like, okay, that's cool, what's the use of it? Well, in the big picture, it's used in so many different things. It's used in astronomy, it's used in navigation, it's used in marine biology, computer science. I mean, it's used in everything that you can imagine. But there's a few specific things that you would maybe use it for in everyday life, even if it's just like a gimmicky thing trying to figure stuff out. So the basics of this, SOHCAHTOA, is a mnemonic device to allow us to remember what sine, cosine, and tangent, what the ratios are. Because that's what this all comes down to. We can figure out the angle by knowing the ratio of two sides and how it relates to the angle. So it's a lot easier for us to be able to do this in our time and place because of calculators. It used to be you would have to have ratio tables and all kinds of things to figure this out. But with SOHCAHTOA, the mnemonic device, and a calculator, any of us can easily figure out the unknown information. So SOHCAHTOA, sine, cosine, tangent. They're the three main trigonometry functions we're going to be using. So that's what we're going to be working out with today. What I need you to be able to remember is what this means. So is sine of an angle is equal to the opposite side over the hypotenuse. What that means is the sine of A is going to be equal to the ratio of A over C. So this will make a little more sense in a minute, but this is what we're really explaining right now. Okay, so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So the cosine of angle A equals adjacent over hypotenuse. So the cosine of A is equal to the ratio of B over C. And then TOA, which is tangent, opposite over adjacent. So our angle TOA, opposite over adjacent. tangent of A is going to be the ratio of A over B. And like I said, I know this doesn't make a lot of sense right now, but this is just cementing what this means. If you can remember this, then in a minute we're going to be able to walk through and figure out how to use these. So, ka, toa is what we want to remember. That's our big lesson today, is to memorize this, and then we're going to get a little bit of understanding of how it's actually used. So sine is opposite over hypotenuse, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And our next slide, you're going to see where this actually comes into play. The idea is, using these different functions, if we have any two of these pieces of information, we're going to be able to figure out this angle. So if the side lengths that we know are opposite in the hypotenuse, if we know what A is and we know what C is, then we can use the sine to figure out this angle. If we know adjacent and hypotenuse, so if we know B and C, then we'd use this function to figure out this angle. And if we know the opposite side and the adjacent side, then we would use this function to figure out this angle. So it's just, we choose which one of these three we use depending on which pieces of information we have. So that's to figure out what this angle is or what the sides are. Okay, so let's put it into practice. Okay, so our next is, how do we use it? So like I just said, if we know an angle and the length of any side, we can find the length of any other side in a right triangle. If we know the length of any two sides, we can calculate the unknown angle. Where we're usually going to use this, though, in most of our starting problems, is we're going to have a side length, we're going to have an unknown side, and we're going to have a known angle. So let's walk through this practically and see how it works, okay? So I've redrawn from the slide just here in paint so we can play around. So we know an angle and we know a side, and we're trying to find the other side. I mean, we can make up a story here. This is some alien spike we're trying to figure out the height of. We're standing 100 feet away from it. We've taken out a protractor and we've calculated the angle, and from where we're standing to the top of the spike is a 30-degree angle. So we know this angle. We've paced out this distance, or there's a marker or something. We know we're 100 feet away and it's a 30-degree angle to the top. So let's go back to our newly understood or remembered ideas of let's go capital. So, ka, and toa. We remember this, right? Okay. So means what? It's sine equals opposite over hypotenuse. Okay. We're trying to figure out the opposite because we've got an angle. And if we were going to use sine, we'd need the opposite and the hypotenuse. Well, we don't know the hypotenuse and we don't know the opposite, so we can't figure it out by just knowing the angle. So that one's not going to work for us. So ka is cosine equals adjacent over hypotenuse. So same issue. We're trying to figure out the opposite. We know the adjacent. We don't know the hypotenuse. We do know the angle, but we're trying to figure out the opposite. That's not in our function. So that one's not going to work either. Toa is tangent equals opposite over adjacent. Okay, let's take a look. We know our angle We know adjacent is 100. We want to find opposite. Okay, we can do this. This is the one we know because our unknown is in here. We have one known. We have the angle, so we can figure it out. So to figure this out, we're going to take the tangent of 30 degrees is equal to the opposite, which is x, right? And our adjacent is 100 feet. Okay, so this is how we'd set it up. We're taking the tangent of a known angle. It's equal to the opposite length divided by the adjacent length. So we can solve this. All we have to do now is grab our handy dandy calculator, and we've got a known angle, so we've got 30 degrees. We're going to take the tangent of it, and this is our answer. So what this is telling us what the ratio of these two is equal to when it's a 30 degree angle. So it's 0. Let's pull that back up here. 5774 is equal to x over 100. Okay, well, we're going to use we know how to solve this equation, right? If we want to isolate x, we need to get rid of this divide by 100, so we're going to multiply both sides by 100, so we'd have our 0.5774 times 100 equals 57.74 equals x. So we know x over here is 57.74 feet. And that's basically how this works. It's not super scary. It's not super in-depth. We'll learn much more about trigonometry later, but right now, that's the basics. If we go back to our ideas here, if we remember our terms, theta is the angle we're trying to find. We know hypotenuse, we know adjacent, we know opposite. We remember SOHCAHTOA. It's just sine is equal to opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. That gives us what we need to work with. We can solve simple problems like this using just that much knowledge. So let's go through here. So that would be my mini lesson, and it was a quick and dirty. Probably take longer when I'm working with the students. We'd work through a few more problems. The next thing I would have them do is, at their tables, 3 or 4 people, play a flashcard game. So there's some different games out there. This is one I found on Teachers Pay Teachers. It's slap math. Basically, you'd get some flashcards that have the sine equals opposite over hypotenuse, and you'd play like a slapjack game. I mean, there's some multiple different varieties. Just something to get the kids to think about that, starting to ingrain that mnemonic device into their head. So you'd have them play that for a while. While they're doing that, I would walk around, spot check, review. If certain students are having problems, certain tables, I would just remind them. If there's some larger issues, like they're not getting it, I would go back, group back up, and teach the lesson as the full group again, just to see if there's any systemic problems that I need to re-cement, or better help with understanding. And then the last thing we do is break everybody up into partners, or even at the tables, depends how many kids are in the class, and then play a SOHCAHTOA classroom game. So what I like for those, and kids really seem to love, are these, it's like a bamboozle. One of the big class-wide games. You know, you can have however many teams. This is, I haven't signed into it, so this one only lets me go up to 2. But the idea is that you'd have this Jeopardy-ish type game up on there. You would have kids, you know, team whoever starts, figure out a way for them to start. They're going to say, we want number 2. Okay, that was a weird one to start with, because that team just got bonus points for no reason. But let's go to 3. Okay, find the measure of angle x to the nearest degree. This would probably be a little advanced for where we're at this point, but I'd go through here and change these to be more like, you know, if we're looking at theta, which sine, cosine, or tangent would we be able to use? Well, it's opposite over adjacent. The answer would be tangent. They would call it out. This one, of course, it's looking for the actual angle, so that wouldn't be it. But you get the overall concept. We're going to play this as a game. It's just helping to cement that SOHCAHTOA mnemonic device. That's the main thing we're doing with this lesson. Not so much having them solve problems, but getting down what we're actually talking about, that it is a ratio function and what it means and what its uses are for. So that was kind of a quick and simple run through of how I would do that, and I think this would be a good first introduction lesson to what trigonometry is and why that mnemonic device is useful. Well, thank you very much for your time, and I appreciate it. Have a great day.